Advanced Financial Modeling, Topic 2, Portfolio Optimization, Learning Objective number 4. We're going to determine the optimal portfolio from a set of frontier portfolios and the capital allocation line from last section that targets either a mean or a volatility. So let's draw this picture to help what we're about to do. In earlier topics, we showed how to create an envelope. That envelope is either maximizing mean or minimizing volatility for some relatively arbitrary levels of return or volatility, and you get an envelope. However, one of these portfolios is better than the others. That is this portfolio in which we draw a line segment from the borrowing rate to the envelope, that tangency portfolio. We'll call it the optimal borrowing portfolio. That portfolio is something pretty special, because here's what we're going to do. If we want any level of return that's greater than this level of return or this level of volatility, I'd rather be on this line than on an envelope portfolio, because these are completely dominated. These envelope portfolios are completely dominated by this levered portfolio, which involves borrowing money at RB and putting it into this portfolio, which we said is right down here. That's the portfolio we're going to invest in, and we can get on that point. However, if we want any level of return that's less than the optimal portfolio, or volatility that's less than the optimal portfolio, then we are on an envelope. So here are your choices for total, we call it combined or complete portfolios. If you desire a level of return or volatility less than this tangency point, run a solver, get an envelope, maximizing mean or minimizing vol. If you want any level of vol or mean greater than this optimal borrowing portfolio, then we just need to figure out how to invest to get on this capital allocation line. I want to bring something or discuss something here which you may have seen in other courses or textbooks. Sometimes a capital allocation line, well, there'll be a second capital allocation line. That is, if there is some risk-free rate of return, say right here, you could say, well, why wouldn't I want to invest in, say, treasuries and invest along this line? And you could. But the way I'm setting up this course, at least for these sections, is I'm going to say there really is not a risk-free rate of return. And in this case, we're always looking at a 1-year time horizon. The best you're going to do is get a money market fund. A money market fund has a very low volatility, say 1 or 2% volatility per year. And that might be, say, this level of return over here. So in my world, there is no risk-free rate, zero volatility risk-free rate. In practice, you would just substitute money market, which would give you just a very low level of return and very low volatility. So that's why I'm not showing you this other capital allocation line. However, in the real world, you can borrow at RB, and in theory, you could create these optimal portfolios. Okay, so I just wanted to get that out there. So let's do something. What if you are trying to create an optimal combined or complete portfolio for 2 levels of volatility? Say you want 10.5% vol and you want the best portfolio, or you want 18% vol, what's your best portfolio? Well, we know that the volatility of this optimal portfolio is 14.7. So if you want 10.5, you're just going to be on an envelope, run a solver. If you want 18, that's greater than 14.7, you're going to be along this line. So let's solve these 2 problems. Let's do the first one. You want a combined or complete portfolio with this 10.5% volatility. You've already done the work to get the envelope, and you have a capital allocation line and an optimal borrowing portfolio, OBP. Since you are targeting 10.5%, as I said, it's just going to be an envelope portfolio, and wherever 10.5 is, you're just going to find that point. So let's go ahead and find that point using solver. So we're going to go back to our spreadsheet, and we're going to go Data, Solver. We're going to minimize vol by changing W, add a constraint. Whoops, I made a mistake. We want, since we're trying to get a 10.5% vol, we want to maximize mean. All right, good. But that's important. We're trying to get the best 10.5 vol portfolio. So what we want to do is maximize the mean, the portfolio mean, by changing the weights and add a constraint that vol is equal to 10.5, so 0.105. Okay, we're going to have constrain ourselves to no short sales in this example and hit solve. Solver found a solution, and here's the solution. I get 10.5 and I get 7.99 expected return. That's the best I can do. I'm going to go ahead and copy this. Copy. Come down here, Alt-H-V-V. So this is that best portfolio. I'll call that portfolio V1. And if we want to add that to the graph, we can come over here. Let's do a right click on the data. Select data. We're going to add, we'll call this V1. And I can just add another name, 10.5 vol. And our X value, the volatility, is that 10.5. Our Y value, the mean, is 7.99. And hopefully it shows up on our graph right at 10.5. So somewhere around here, and hit OK. OK. And there it is. Notice it is right on our envelope. And here's our optimal borrowing portfolio. And there is that optimal portfolio for 10.5 vol. Now, if we want a 13.79 vol, if we just did the same procedure, we would wind up with a portfolio along this line here. It would be just on this point over here. So what we're going to do is we have to determine how much money to invest in an optimal borrowing portfolio to get 18 vol. We're targeting an 18 vol. So let's go back to the PowerPoint, and we have to do a little bit of a calculation. Since we're looking for an 18% vol, that's our total combined. That's going to be somewhere out here, and I want to get on this line. I just need to figure out a formula to get to a point on that line. And here's what we do. It's a two-step process. The first thing is you need to find out how much money you need to invest in that optimal portfolio. That's this optimal portfolio right here. How much to invest in it. Once I know that, I can then use that weight to then calculate the standard deviation and return of the portfolio. So if you're targeting a vol, you're going to use this calculation. My weight in the optimal borrowing portfolio is going to be the total standard deviation in the complete or combined portfolio. That is our targeted vol. That's going to be the 18%. My total vol is going to be 18. And divide that by the vol of the optimal portfolio, 1479. So 18% divided by 1479 is 122%. So let's go ahead and do that in the spreadsheet, and it looks like I've already done that for you. I just took 18 divided by 1479. Notice if I put 122% of my money into that risky portfolio, OBP, that means I have minus 22% of my money in the borrowing rate. So let's put this in perspective. What does this actually mean? If I had $100, I would borrow $22 at RB, which is 6%. and put that $122 into the optimal borrowing portfolio and borrow $22 at 6%. So what's the return of that portfolio? Well, I'm going to get 122% of the return of the optimal portfolio, which is 9.33, but I need to pay off the interest charge. So I'm going to say minus 22 times RB, which is at 6%, and the best I can do is 10.05. So you're going to get 122% of the return minus the 22% borrowing. And last thing we're going to do is, how do I actually build the portfolio? Well, take 122%, anchor that, times OBP's weight in US equities. I'm going to copy that across since I anchored the weight. And notice how if I look at the sum of these, they add up to 122%. So here's how I'm going to build this exact portfolio. If I had $100, I'm going to borrow $22. I now have $122. I'm going to put 84 into equities. I'm going to put 37 into emerging market, and that's going to be my $122 invested. Okay, so that's it. That's how you determine an optimal vol portfolio when you're targeting greater than the optimal borrowings vol. Now we're going to look at a very similar problem, and that is, what if I don't have an overall vol target? I have a mean return target. In other words, I want to build the best 6.5% mean return portfolio, or I want to build the best 9.5% mean portfolio. Remember, the optimal borrowing portfolio has a mean of 933. So if you want 6.5, you're going to have to run a solver, because that's going to be on the envelope. If you want 9.5, it's going to be on the capital allocation line. So let's find our portfolios. First thing we'll do is run a solver and find the best 6.5% mean portfolio. Switching back over, data, solver. I want to minimize vol by changing W, and then I want to delete this constraint on vol and add a constraint that the mean is equal to, what do we say there? 6.5. 0.065. Okay. Solve. Solver found a solution. There it is. That's your best 6.5% mean portfolio. Looks like I'm getting US equities, emerging equities, some bonds, and some money market. I'll copy those values, copy, and paste it here. Alt-HVV. 100% of my money's in that in a risky portfolio, an envelope portfolio. And then the last problem is, how do I build the best 9.5% mean portfolio? Slightly different formula than last time. If you're targeting a mean, you can't just take a ratio of the 9.5 and the mean of the optimal borrowing portfolio. What you have to do is you have to use this equation. My 9.5%, take that minus RB, divided by the mean return of the optimal borrowing portfolio, 933 minus RB. So it's a 9.5 minus 6%, divided by 9.33, divided minus 6%. That is equal to 1.05, or 105%. So, drawing a picture, I have my envelope, I got my tangency line. I'm going to put 105% of that money into that optimal borrowing portfolio, and it's just going to be right next to that point right there. So, back to the spreadsheet. Looks like I did the calculation for you. I'll take my 9.5 minus 6 divided by my 933 minus 6. The 933 is the mean return of the optimal borrowing portfolio. That means I'm borrowing 5% of my money. So if I had $100, borrow $5 at 6%. And my volatility, oops, I lost the word volatility, I'll copy that there, is going to be 105% of the volatility of the optimal borrowing portfolio. So you're going to get 105% of the vol, 1556. All right, 105% of the vol. What's my weight in U.S. equity? 105%, anchor it, times the weight in the optimal borrowing portfolio, 6921. Copy that across. Notice how these all add up to 105%. So how do I build the best 9.5% mean portfolio? If I have $100 to invest, borrow $5 more at 6%, take that $105, put 72 into U.S. equities, 32 into emerging market. Well, it looks like 73 in U.S. equities. That's your 105, and you had that $5 you've borrowed at 6%. So that's it. That's how you determine an optimal combined or complete portfolio if you're targeting mean or volatility. And there's our solution. If you add those points to the graph, what you'll see is those last 2 points we got, the 105, it's on that capital allocation line, and that 9.5 would have been on the envelope. Whoops, 9.5 would be on the envelope. That's right there. And the other points are shown also. So this is how you target an optimal combined or complete portfolio using leverage and borrowing. If you're interested in some more information, here's some good resources you can click on, or a couple books you can read. Capital Ideas and Capital Ideas Evolving is a really good book about the origins of these ideas. And the classic is Random Walk Down Wall Street. And the neoclassic is Fooled by Randomness. Talks a little bit about this type of problem, but it's kind of critical of using standard deviations, so watch out. So in this topic, we determined how to form an optimal complete or combined portfolio, either from a set on the either a portfolio on the set of frontier portfolios or a point on the capital allocation line. In the next topic, we'll just talk about using VBA comments and the application object thing in VBA.